Welcome, learners. In this video, we will talk about the encapsulation topic in Solidity. Encapsulation is indeed fundamental concept in object-oriented programming languages. It involves controlling the visibility and accessibility of variables and methods within a class or object. So the main idea behind the encapsulation is to bundle data and related methods together, hiding the internal details and providing a controlled interface for interacting with the object. So in object-oriented programming, the scope of objects can have 4 types of access. We have here at the first public. Public access allows unrestricted access to variables and methods from anywhere in the program. So public members are accessible by other objects, classes, or modules, and their values can be read or modified directly. About the private access here, this is the private. About the private access restricts the visibility of variables and methods to only the class or object in which they are defined. So private members cannot be accessed or modified from outside the class. They are typically used to encapsulate implementation details and provide data integrity. So in Solidity, private objects can only be accessed internally from the current contract, not classes here, from the current contract instances. They cannot be accessed by derived methods also. About the internal here, in the internal access or internal package or internal, or we can say it sometimes call it package or private access, restricts the visibility of variables and methods to the current package or module. Internal members can be accessed and modified by other classes or objects within the same package or module, but are not accessible outside of it. This access level is useful for creating encapsulated units of code within a larger program. But I talked here about classes. Here, internal objects can be accessed by internal methods or by derived methods, but cannot be accessed by external ones. Only the base contract and derived contract has its access. So now in Solidity, we should talk about contract, not classes, okay? About the public, these objects can be accessed externally, but not internally. For example, current contract instances cannot access it. They cannot be inherited. So by using these access modifiers, encapsulation provides a way to control the visibility and accessibility of variables and methods, and ensuring that they are accessed and modified only in the inherited manner. So this helps in organizing and structuring code, promoting code reusability, and enhancing also the security and data integrity by preventing unauthorized access or modification of internal details. Okay, we will talk about now this example practically. Let's go to the code here. So let's break down the code line by line here. SPDX, this line specifies what? Specifies the SPDX line, software package data exchange license identifiers, which is a standard format for what? For exchanging software license information. In this case, the license identified by GPL, this means General Public License 3.0, is used. The second line about pragma statement used to specify the version of the Solidity compiler to be used for compiling the contract. In this case, specifies version should be greater than or equal 0.6.12 and less than 0.9.0. Then we have a contract parent. These lines are actually these lines in the green color means comments. Okay. About the contract, declared public state. We have here public state contract here line. This line 4 starts the declaration of parent contract. Okay. The next line, which is num equal 30, this line declares the public state variables num of type uint, this means unsigned integer within the parent contract. And the public visibility keyword means the variable can be accessed, sorry, can be accessed and read from outside the contract. Okay. So this variable with public visibility. Uint internal here, internal, this line declares an internal state variable, internal num of type uint also within the parent contract. The internal visibility here means what? Means that the visible or the variable is accessible within the contract and any derived contracts, but not from outside the contract. Okay, so this is the visibility of internal. Now we have a function sqrt. This function here and has the function here named sqrt, and look at this keyword, which is external. This means doesn't take any parameter, actually, this function. This is the visibility of this function. Calculates the square of the internal num variable and updates its values. Okay, the function here returns the updated value of internal num. So again, this function named sqrt and has an external visibility keyword, doesn't take any parameters. Okay, calculates the square of the internal num variable and updates its value. The function then returns the updated value of internal num. Let's go to the contract caller here. This line starts the declaration of the caller contract. Then we have creates an object C of type child, as you see here, that is initialized with an instance of the child contract. And we have here function f. This means this function named f and has a public visibility, as you see here. It doesn't take also any parameters. It calls the sqrt function of the C object, which is an instance of the child contract. So this demonstrates how a function from a derived contract can be called through an object of the parent contract. Now we have function f2. This function named f2 and has public visibility keyword. It doesn't take any parameters, calls the increment and add functions of C object, which are defined in the child contract. It returns the results of both function calls. Okay. So here in F2, we call the two function in the child. Let's see the function child. Okay, this function child starts the declaration of child contracts, which is derived a contract that inherit from what? From parent, as you see here, using is. Okay, then we have now function increment. We have two functions. Here we have this function, sorry, in child only. Yes, function increment. Okay, this function will be what? Named increment, has a public visibility, as you see here, public visibility, and marked as a payable, meaning it can receive either value. It increments the value of the num state variable by 20 and returns the update value. So increment or add 20 to the num, and so update the value, the variable num, then return the updated value. We have here also function named add, has the public visibility also, marked as a pure, as you see. This meaning it doesn't read or modify the contract state. It declares the 3 local variables, A, B, and sum, and assigns them values about A and B, and the sum has the value of A plus B. Then return the result, which is in some variable. So the child contract demonstrates how and I am okay. So this is the contract child, which is inherited from the parents. Okay. Let's combine this code. And then we go to the contract. We should assign the caller function or contract, then deploy. Then we have here we have function 1 and function 2. We can call the 2 functions and see the result like this. You can see the result of function F1. We have here 100. We can go to the F, which is calculate the SQRT. SQRT of what? Of the numbers in the, here we have the internal number 10. Okay. Then the calculation here will be processed. Then we can get the result of F100. About F2, we got the result 50 and 30. Look at the function F2, which is increments. We have 2 functions return with the result of 2 functions. 2 functions, increment function and add function. Increment function means add 20 to the number and return the result. And we have also add function, which means the calculation of A and B, 10 and plus 20, and the result will be 30. So this is the result of function 2. I hope this topic is clear now. It's about encapsulation in Solidity, and we learned about the objective and the purpose of using encapsulation in the Solidity. Thank you for watching.